Hi everyone. Today we are going to explore how a Lambda function in a VPC can access the internet safely using NAT gateways with a multi-edge setup for high availability. Now let's look into the architecture. In this diagram on the top left you can see we are in a US East 1 region. Inside it we are creating a VPC called a demo VPC. Inside demo VPC we have two availability zones, US East 1A and US East 1B. In each of these availability zone, we have two subnets, one private and another public. Private subnet is denoted by a blue box, whereas green box represent public subnet. Now let's look into this Lambda function called app Lambda, which is VPC enabled. When a Lambda is in a VPC, AWS creates an ENI, a virtual network interface in the subnet. This gives the Lambda a private IP so it can communicate inside the VPC and reach the internet through the NAT gateway. We can see that we have two ANIs in each private subnet. For both private subnet A and B, we need to add a route in the route table which points 0.0.0.0/0 to its corresponding NAT gateway. We also need to create a security group called app lambda SG, which will allow all HTTPS traffic to the side range 0.0.0/0. In each public subnet C and subnet D, we have individual NAT gateway. NAT gateway in subnet C provides internet access for private subnet A, whereas NAT gateway in public subnet D provides internet access to subnet B. We see we have an internet gateway attached to the VPC, which allows NAT gateway in public subnets to reach internet. Now that we understand the architecture and how traffic flows from a private Lambda to the internet through a NAT gateway, let's switch to the AWS console and test this in action. Now that we are in the AWS console, let's open VPC. In this VPC console, click Create VPC. Under this VPC setting, let's give this VPC a name. Scrolling down, number of availability zone is set to 2. Number of public subnet is also set to 2. Number of private subnet is also set to 2. All of these three settings are fine for our demo purpose. Scrolling down in VPC endpoint, let's select none as we won't be needing VPC endpoint for this demo. Here on the right under the preview, we can see we will be creating a VPC called demo VPC. We can see we will have 4 subnets. The 4 subnets will be divided into 2 availability zones, US East 1A and US East 1B. Each availability zone will have a public and private subnet. For example, we can see public 1, private 1 and public 2, private 2 in 2 different availability zones. Under route table, we can see that private subnet on each availability zone has its own route table, whereas public subnet from both availability zones shares a same route table called demo RTB public. We can see that route table of a public subnets has a network connection called demo IGW, which is an internet gateway. So route table for public subnet will have a route to the internet gateway. The creation of this VPC also gives us this internet gateway called demo IGW. Now let's click create VPC. Let's wait till the VPC gets created. Now we see all VPC's resources and services are created. So let's click view VPC. Under resource map, we can see now we have our VPC subnet route table and network connection being created by the VPC called demo VPC. Now that we have successfully created a VPC, let's move into the diagram. Here we see we have 2 NAT gateways in 2 different public subnet of 2 different availability zone. So now let's create these 2 NAT gateways. In this VPC console, on the left hand side, under Virtual Private Cloud tab, let's click NAT Gateways. Let's open two tabs for two NAT Gateways. In the first tab, let's click Create NAT Gateway from the top right. Let's give this NAT Gateway a name. On the availability mode, we will be selecting zonal. Under subnet, we will be selecting this demo subnet public 1 US is to 1A subnet. For connectivity type, we will be using public. For elastic IP allocation, let's click allocate elastic IP. Please note that we have successfully given an elastic IP called 3.221.139.79. So let's click create NAT gateway. You can see we got a message called NAT gateway NAT 0651B3 NAT G1 was created successfully message. Under detail, we can see that the state is still pending. So let's move to the second NAT gateway tab and create a second NAT gateway in different subnet under different availability zone. Here let's click create NAT gateway. Let's give this NAT gateway name. Again, let's select zonal as availability mode. For subnet, we will be selecting a different subnet under different availability zone this time. So we will be selecting the second option, US is to 1B. Connectivity type will be public. Again, allocate elastic IP. Now we are given an elastic IP called 52.200.45.52. Now let's click create NAT gateway. Under details, you can see the state is still pending. Let's move to the first NAT gateway tab and see if the status has changed. So for the first NAT gateway called NAT GW1, the state is available. For the second NAT gateway, let's refresh the page. You can see the state is still pending. So let's wait for a while. Finally, we can see that the NAT gateway 2 has a state as available. So let's move to the diagram again. So we have successfully created NAT gateway 1 and NAT gateway 2. We can see that we need to make or add a route in a private subnet where 0.0.0.0/0 will point to the newly created NAT gateway of the corresponding availability zone. So let's make a change to the subnets route table by adding this route. In this VPC called demo VPC console, let's open the private subnet route table. So we have this private subnet called demo subnet private 1 US is to 1A. So let's follow this and open this private route table called demo RTB private 1 US is to 1A. So let's open this route table. In this route table, let's add a new route by clicking this edit routes. Click add route. Let's select 0.0.0.0/0 to NAT gateway and we will be selecting NAT GW1 and click save changes. We can see that we have successfully added a route to the NAT gateway. So what it does is, if we have an address that is in the range of this CIDR 10.0.0.0/16, then it will have a target of local. So it will be routed inside the VPC. But when the address range is out of this CIDR, then all the requests will be sent to the NAT gateway. So now let's move on to the route table of second private subnet called demo RTB private 2 US is to 1B. Let's open this. So please remember, we are working with US is to 1B availability zone right now. So let's open this. Again, click edit routes, add route. Here we will select NAT GW2 NAT gateway. Let's click save changes. We see that our new route has been successfully added. Now let's move to the diagram. One important thing to note is that we have two private subnet route table in two different availability zone, 1A and 1B, and each private subnet's route table should point to its corresponding NAT gateway, since we have two different NAT gateways. Now let's create security group called app lambda SG with appropriate outbound rule. Moving into this AWS console, let's open security group. Let's click create security group. Give this security group a name. Under description, let's put dot. Under VPC, let's select our VPC called demo VPC. For outbound rule, let's delete this rule and add a new rule with https to 0.0.0.0/0. Now let's click create security group. We can see we have successfully created a security group called app lambda SG. Now let's move to the diagram. In this diagram, we can see we have a VPC-enabled Lambda function called app lambda. So we will be creating a Lambda function called app lambda that will be attached to two different private subnets in two different availability zones. So let's move to the AWS console. Here, let's open Lambda. Click this create function. Give this function a name. We will choose runtime as Node.js. Scrolling down, click this additional configuration. Let's click enable for VPC. And under VPC, let's select our VPC called demo VPC. Under subnets, let's select both of the private subnet in US East 1B and US East 1A. So let's click this security group drop down and select our security group that we recently created called app lambda SG. Scrolling down, now we can click create function. Let's wait till the function gets created. Alright, we got the message saying the function app lambda was created successfully. So scrolling down under the code tab, let's ignore this. Let's replace this with a new code. I will be attaching this code in the description. Here we can see that we are calling a public endpoint or API called JSON placeholder.typecode.com/todo/1. So what we are essentially doing is we are making an request to the internet to the public endpoint, and we are resolving it to the status code of 200 and the body with the value of data that we got back from the public endpoint. So let's click deploy. Again, we see the message successfully updated. So let's move to the test tab. In the test tab, let's click test. We can see that our function was executed successfully. So under details, we can see that we got back the status of 200 with body, user ID 1, ID 1, title, and completed with value false. So this confirms our Lambda in private subnet can reach the internet via NAT. To avoid unnecessary charges, we will clean up unused NAT gateways and their elastic IPs. So let's move to the NAT Gateways tab. So let's move to this NAT Gateway 1. Under action, let's click delete. Let's confirm. Under NAT Gateway 2, let's repeat the same steps. Let's wait till the state of both the NAT Gateway NAT GW1 and NAT GW2 state gets to deleted. Now we see the state as deleted for both NAT gateways. Let's go to the VPC console. Under left hand side, under Virtual Private Cloud tab, let's click Elastic IPs. We can see that we have two Elastic IP that was allocated to the NAT gateway. So let's open this Elastic IPs in new tab. Under action, let's click Release Elastic IP Addresses. Let's move to the second tab. Again, do the same. For this Elastic IP, click Actions and click Release IP Addresses. Click Release. That's it for this demo. If this helped you understand VPC-enabled Lambda networking, please like and subscribe. See you in the next one.